Okay, know how to take a conic section like this and then put it in standard form, sketch a graph, and describe what it is. So what you're going to do is you're going to complete the square. So I'm going to have x squared minus 2x plus something else. All right, and then I'm also going to have the y squared, so I'm going to have plus y squared minus 4y plus something else is equal to negative 5, so I'll move the number over to the other side. Now I need to add something to this to complete the square. That's b over 2. You always add b over 2 squared to complete the square, so it's negative 2 over 2, which is negative 1. So it's negative 1 squared. And then negative 4 over 2 is negative 2 squared. All right, now if I add negative 1 squared, that's really 1. I need to add 1 to the other side. Negative 2 squared is really 4, so I need to add 4 to the other side as well. Okay, that gives me 0 on the right side. And then these become perfect square trinomials, so it's x minus 1 squared plus y minus 2 squared. Okay, so, and you won't have one quite like this because this is a circle with radius is 0. So it's a circle centered at 1, 2, with a radius of 0, so it's just a dot, it's a point. Okay, it's a circle that's been translated over 1 up 2, but it doesn't have a radius, so that's not a very good one to look at. Let's try one more. Let's try this one. So we're going to complete the square on the x's, so we have 9x squared minus 72x plus something else, and then we have the y, so we have minus y squared plus 8y plus something else equals negative 119 if we move the 119 over the other side. So I've rearranged this. Okay, now I'm going to factor out a 9 from this, in which case I have x squared minus 8x plus something. And then I'm going to factor out a negative 1 from here, in which case I have y squared minus 8y plus something else equals negative 119. Okay, now I'm going to add b over 2 squared to both sides, which is negative 8 over 2, so that's negative 4 squared. Then here, it's negative 8 over 2, so it's negative 4 squared as well. Now, this is really 16 right here, but I'm multiplying it by 9. So that's 16 times 9 that I'm adding to the right side. As well as this right here is negative 4 squared, which is positive 16, times negative 1 is a negative 16. So I'm adding a negative 16 here, which means I need to add a negative 16 here as well. Okay, this then becomes 9 on the right side. These are perfect square trinomials, so you'll have 9 times x minus 4 squared minus y minus 4 squared. Okay? And then if I can see this as a hyperbola. If I divide through to get a 1 here, then these cancel and you end up with x minus 4 squared over 1 minus y minus 4 squared over 9 equals 1. So that's a hyperbola, and it's in standard form now. You can compare it to your formula sheet, and you can see that for hyperbolas right here, we have our our x comes first, and then our y, right? Yeah, our x comes first, and then our y. So the focal axis is vertical line, which means this is a horizontal line. This is a horizontal hyperbola. In chapter 5, this one wants us to evaluate their logarithm using change of base. One's with common logs, one's with natural logs. So they'll be the same answer, but with common logs it'd be base 10. So you do log of 6 over log of 2. Both of these are base 10. And then that'll be equal to the same thing if you use natural log. It doesn't matter what base you use. And you can do this in the calculator to prove that you get the same thing. Common log of 6 divided by common log of 2. You do the same thing as if you did natural log of 6 over the natural log of 2. Okay, so 2.585, approximately, rounded to 3 decimal places. Okay, know how to use log properties to solve equations. For example, this, the difference of two logs, I can make that a log of a quotient, going backwards with my properties, right off your formula sheet. This equals the log base 6 of x plus 5. And, I mean, there's different ways to solve this from here. You can basically compare, you can set this equal to this now if you want. Or you can raise both sides to the 6th. You can make these exponents, in which case these would cancel. You could bring it down either way, or you could subtract this from both sides and use more log properties. I guess I'll try that way. Log base 6 of x plus 2 over x minus log base 6 of x plus 5 equals 0, in which case make this a quotient. Just want to see if this way works. This isn't the easiest way probably, but divided by x plus 5 is the same thing as multiplying by the reciprocal, so I'll multiply by the reciprocal instead. And that equals 0. And so then I could just do 6 to the 0th base to the exponent equals the argument over x times x plus 5. In which case this is just 1. So I could cross multiply. In which case this would be x times x plus 5. And then I could solve. So distribute x squared plus 5x equals x plus 2. Subtract x, that gives me x squared plus 4x minus 2. If I move these things to the other side, equals 0. And I don't know if I can factor this or not. No, it doesn't factor, so I'd have to use the quadratic formula to solve it from there. I'm going to go up and now do it a different way real quick to see once if I get the same thing. So from this step now, I'm just going to erase these, see, because I can do that. I can say compare one-to-one property, in which case I cross multiply and I do get the same thing. X plus 2 equals x squared plus 5x. And when I subtract the 2 and the x, I get the same exact thing. So either way, it would be a lot easier to do it this way because then you go right from there to this step right here. Either way, you end up solving with the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In which case these double negatives go positive. I end up with 8 plus 16, which is 24, over 2. I'm going to make this the same as 4 times 6. 6 times 4. That way I can evaluate the square root of 4 as 2. Pull that out. And then the 2 goes into 2 one time, goes into 4 twice, so I end up with negative 2 plus or minus the square root of 6 as my two answers for x. Okay, I should check those and make sure they're both working now, and one of them not extraneous. I'll let you guys plug that decimal into your calculator if you want to check this equation. But this would be the two answers. Okay, let's use properties of logarithms to expand this. So we can make the log, we have a property in our formula sheet that says we can do the quotient, we can make that a difference. So the natural log of 5 square root of x minus the natural log of 6. And then we have another one that says that the product, we can make that natural log of 5 plus natural log of the square root of x, which I'll write x to the 1/2 instead of square root of x. We still got to subtract the natural log of 6. And I can bring this down as 1/2, this exponent down. We have another property that says you can do that. And that's good. That's expanding it as far as we can go. It's a sum, a difference of constant multiple logarithms. Okay, let's try one more. In which case we're going to use that same properties but go the other way around, and then this time solve an equation. So we're going to go that way around with a sum, two logs, and make it a product. Log of x times x minus 15. And then that's equal to 2. From there, we'll change it to exponential form. We'll do base, which is base 10 is the common log. 10 to the 2 equals x times quantity x minus 15. And this is 100. And then I'll distribute the x to both of these terms. X squared minus 15x. And I'll subtract the 100 as well, so I can get this in standard form for a quadratic. And then I'll try to simplify. I don't know if this factors. Negative 20 and positive 5. It does factor. That makes it easy. That way I don't have to use the quadratic formula. X equals 20, x equals negative 5 on my two solutions. And I should check those to make sure they're not extraneous, because one of them could be. So I'll just try. Actually, log of negative 5. I know a log looks like this. I know it's not defined back here. It's not in the domain. So I'm guessing this is extraneous. It is extraneous. Because that's going to give you an error when you type in log of negative 5 in your calculator. But the log of 20 is okay, so 20 is a solution. So there's only one solution, x equals 20 for this one. Okay, x equals negative 5 is extraneous. All right, I hope this helps.